Welcome to Lloyd and Stephen's explanation of MOSFET modes, narrated by Stephen Glover. This is a MOSFET. This is its gate, this is its drain, and this is its source and base, usually connected. A quick explanation of how a MOSFET works is, as a voltage is applied to the gate, it creates a channel in which electrons can travel from the drain to the source. To simplify the explanation of the MOSFET, I shall use the analogy of a gumball dispenser, as shown in the picture. The gumballs represent electrons. The voltage at the drain is represented by the mass of gumballs at the top, which is magically refilled. The gate voltage is represented by the purple dispenser button. The source is at the bottom, where the gumballs come out. In a MOSFET, in order for the channel to form, the gate voltage must be greater than a threshold voltage. In the gumball dispenser example, this is shown as a spring representing the threshold voltage pushing back against the button. A MOSFET has three modes of operation. The simplest of these is the cutoff. Cutoff occurs when the voltage at the gate is less than the threshold voltage. In the gumball dispenser, this means you haven't pushed the purple button hard enough and the spring is keeping the tube closed. As you can see, no gumballs can get out. Similarly, when the gate voltage is below the threshold voltage, no electrons can get from the drain to the source. Therefore, there is no current through the MOSFET. The second mode is the linear region, also known as triode. In this mode, voltage at the gate is greater than the threshold voltage, and also the gate voltage minus the threshold voltage is greater than the drain voltage. In the gumball model, this means there is a few gumballs at the top, and the path is opened as the gate voltage is greater than the threshold voltage. So a couple of gumballs trickle down to the bottom. This mode is known as linear because while in this mode, the gumball flow is related directly to how hard you push on the button. The more you push down, the more can fit through. Push a little and a few can trickle through. Push harder and more can come. There is of course a limit, which leads us to the final mode. Saturation mode. In saturation mode, gate voltage is greater than threshold voltage, and the drain voltage is greater than the gate voltage. There is a large number of gumballs at the top of the dispenser, but only so many can fit through the tube at once. Due to physical properties, you see, the tube is of a fixed size. Thus, it is said to be saturated with gumballs. Similarly, the MOSFET is saturated with electrons, and no more can squeeze through. Thank you for watching our video on the explanation of the modes of a MOSFET.